What we're going to do today is continue discussing Java streams, and we'll start getting into more examples. Up to this point, it's been relatively conceptual with a few tiny little examples here or there. Today, we're going to start going into a lot more detail. So we're going to start out by talking about a case study program that we'll be discussing that we'll use throughout the next few lessons in order to kind of make everything nice and concrete. So this is the example. It's called the SimpleSearchStream program. You can find it at the link at the bottom of the slides. That's on my GitHub repository. So please take a look there in the live lessons repo in my GitHub repository. And you'll see an example here that we use to demonstrate key Java sequential streams capabilities. You may wonder why we're starting off with sequential streams, because the course is a parallelism course. And the answer is very simple. It's absolutely trivial to take a sequential stream and turn it into a parallel stream. So learning how to do sequential programming makes the parallel programming so much easier. So we'll begin just by kind of visualizing what this program does. As usual, I always find it helpful if you kind of see the big picture before we dive into the source code. Of course, I do show you snippets of source code on the right-hand side. It's just not formatted in the way you would compile it, but it still illustrates more or less what's happening. So what this program does is it finds words in an input string. So you give it an input string and it goes and it searches for words. And it uses a little stream here to do that. Just for fun, we're going to use the words from a famous song from the musical The Sound of Music. And it's called the Do Re Mi song. And we'll go look up the words Do Re Mi Fa Sol La Ti and Do. But we already had Do once, so we don't need to have it twice. And we'll go and see if we can find how many occurrences of those words appear in the particular lyrics to the song. And of course, we'd expect to find them because they appear all over the place. This example is picked because it showcases a bunch of Java functional programming features like lambda expressions and method references, along, of course, with Java sequential streams. And this is a view of what the output looks like. So you give it this list of words, and it comes back and it tells you for each word that you searched for where it appeared within the text of the song. If you think of the song as a big array, where you start at a certain offset, then you can see what the results are. So we can see that the word ray matched at starting at location 131 and 141 and 151 and 202, et cetera, et cetera, et cetera. So it basically just kind of shows you where things are going to be found. There's also some other ways we can search and print the results. There's another way of doing things where we have this kind of a slicing approach where you can say, go ahead and find where the word la appears first, followed by anything else that comes after it. So that appears later in the stream, and that uses some other features we'll talk about called drop while, which is a so-called short-circuiting operator. We'll talk about short-circuiting operators here in a second. This is what the main test program looks like. This particular part of the code isn't particularly functional. It just gets the job done. As you can see, if you take a look at the main program here, it opens up the input file, which is going to contain the contents of the Do Re Mi song. It then goes ahead and opens up another file and gets a list of words we want to look up. We use files here so we can easily change the way this works without having to rewrite the code. Classic way of parameterizing something by a level of indirection. So we open things up in files and pull them in that way. We then create ourselves an object called a word searcher, and we take the input, which is this string that contains the lyrics, and we kind of wrap a word searcher around it. We'll take a look at what a word searcher is here in a minute. And that will be used to search for the words, as the name implies. And then down here, we go ahead and we say, searcher, find words. We give it the list of words to find, which of course is a list of strings. And it gives us back a list of so-called search results. Search results just keep track of where the word appears, if anywhere, or where the words appear, if anywhere. So we get a list of search results, and then we go ahead and we print those search results. So that's kind of the driver program. Again, this is more kind of object-oriented than functional, but when we take a look at the underlying implementations of the methods, in particular, methods like get input, get word list, find words, all those good things, they're the ones that actually do the functional programming using streams. So that's the end of our very quick intro. Nothing particularly profound here, just giving you something so that the rest of the examples we talk about will make a little sense. As always, you're welcome to go ahead and try the code. You can clone my repository and try the code to see how it works for you.